So Sam will talk about location-specific TinyML model calibration. So Sam, please go ahead.
Thank you. So my name is Sam LEROUX. I'm a postdoc at Ghent University and a research engineer at HotG. And today I want to talk about an idea we had of location-specific TinyML models. So we are all here because we are interested in efficient machine learning architectures and hardware platforms to support them. And what these actually allow us to do is to add intelligence and add intelligent data processing close to the sensor that is actually collecting the data for our machine learning model. So if you think about it, the model instance is actually always seeing data from a specific sensor instance. So it's actually fine if our model is overfitted a little bit to a single sensor instance. The model or a single model instance only needs to work well for the data that is coming from a certain sensor or a certain location. It does not need to generalize to all possible locations. So in this slide or in this presentation, we would argue that in some cases it's useful to have a large set of different models, probably all sharing the same architecture, but trained on slightly different data. So a large set of models that are each specialized in a single location, instead of having one big general model that can generalize to all these different locations. So there are a lot of applications that could benefit from such an approach. I've listed a few here on this slide. Anomaly detection, for example, if we want to use machine learning for predictive maintenance or to detect anomalies in industrial machines. We have a lot of different machines that are all slightly different or have slightly different operating conditions. So instead of having one big model that can detect faults in all of these machines, maybe it's a better idea to have very small models that are specialized for each individual machine. Another example is image recognition. So if we add intelligence to a surveillance camera, for example, by performing object detection, we probably know beforehand what kind of objects will appear in front of a specific camera. So there is no point in deploying a big model that can recognize all possible objects. No, we should make very small models that can only recognize those objects that will actually appear in front of the camera. Or a third example, voice recognition. Sure, we could build a large model that can deal with all kinds of different accents and different persons, but maybe it's enough to have a single model that is specialized for a certain person, the actual user that will use the model and provide input to the model. So these are all arguments of examples of why it might be useful to have a lot of different machine learning model instances instead of having one big model. But of course, the problem with having a very large number of these model instances is that you have to manage all of them. So that's where two tools that we are developing at HotG might help you. Rune and Hammer. Rune can be seen as kind of a Docker system for machine learning applications. It allows you to package your TinyML model together with any application code needed for pre-processing or post-processing. And it allows you to wrap it in a portable container format that you can deploy on different hardware platforms. So this tool gives you the portability needed to have such a deployment. And then to actually manage a large number of these running containers, we introduce Hammer. And Hammer can be used to manage all of these containers, to test them, and also to push new Rune containers to all of these devices. So together, these two tools will allow you to build a very complicated deployment, like I illustrated before, where you have a very large number of different models with slightly different weights running on all kinds of devices. So this was very briefly an argument for a very large number of small specialized models. If this is interesting to you, please feel free to reach out to us, check out our developer website, or just connect with us for any questions or remarks you might have. Thank you.
Thank you very much, Sam. I would like to acknowledge again our sponsors. The sponsors are the ones that actually made having a free registration for everybody possible, starting by Newton.ai, who is innovating into the automated TinyML domain, who's also our premier sponsor. Next, we have the executive sponsors. We have ARM, which, as you know, builds from both the software and the hardware foundations for TinyML. We have Edge Impulse, who is advocating strongly, as you all know, for TinyML available to all of the developers. And of course, Qualcomm, who is working as, among other perception, reasoning, and action, and edge and cloud devices in various sectors, such as the Internet of Things, automotive, and mobile applications. And Sentient, who is moving artificial intelligence from the cloud to the edge, which, as you have seen today, it's quite now the trend nowadays. Next, we have our platinum sponsors, Infineon, part of your life, part of tomorrow. We have seen a few of their projects that they work today. We have Reality AI, who is working also in pre-building, pre-built edge AI sensing modules and tools. Next, we have our gold sponsors. Latent AI is the first one who works on adaptive AI for the intelligent edge. Then we have SenseML, which works on building smart IoT sensor devices from various data. And last but not least, our silver sponsors, EMEA from Israel, Greenwaves, HOTC, Magimop, Quixo, Seed, Studio, and of course, ST Microelectronics. I would like to thank everybody that stuck around until now, and I hope to see everybody tomorrow at 4 o'clock Central European time